or actually afternoon. It's a rather nice day today. Today I thought I'd show you a little project, and I had this thing in use a while back, and it was actually a much larger setup, but I want to show you what I've got put together out here and what it's doing. It actually is running the light that is illuminating this video up there, and all the other lights in the house when I have it switched over completely. And let me go out and I'll show you what it is. A little project that I have resurrected recently, and here it is. But this is what I wanted to show you. I finally got two of the many panels that I have up, and we're making just enough power to keep the lights on. And these two panels in parallel are making 160 watts. And that doesn't seem like a lot, but if you consider 12 volts at 10 amps is 120 watts, it's actually, these are putting out more than a store-bought battery charger. A good one. One of the things that was really cool about this was this house, for whatever reason, they had a clothes dryer in this back bedroom. So I have this 4-inch hole here in the wall that I can run wires through, and I've sealed it up around the wires with cloth just temporarily. Eventually we'll sheetrock that, but that orange wire there, that's the number 12 wire coming in from the solar panels, and it goes up to not this Harbor Freight panel, but this panel, which is upside down, and I apologize. That is a SunForce 30 amp hour or 30 amp controller, and that's what is charging our deep cycle battery. Those two panels produce enough amperage to charge my one battery about half a day when I have good full sun. Good controller. It's 3-stage charge controller. It's not MPPT. I'd love to have one of those, but I can't afford one. I'm not rich and I'm not made of money, but that's beside the point. Anyway, that feeds down. This is a very basic setup. It comes down off of there and goes to this deep cycle battery. Here's an informational thing that you may want to know. If you ever build something like this, don't use regular car batteries. They don't hold up, they don't last. That's where I'll leave it at that. I'll actually do a thing on batteries later on, probably in another video. Now what happens, you can run things all day long on 12 volts here if you wanted to, but you want to be able to power the things in your house, so you have to have a device on there called an inverter. This is an inverter. It takes the 12 volts in from the battery and steps it up to 120 volts here. These are just very basic cheapies. This is a really good inverter. This is a Cobra 800. The one below it is a 1500. They're modified sine. Again, I'm not made of money, and I don't have a money bag relative to give me money. So I have to buy these things. So modified sine. And they're good for most things. Computers actually don't have a problem with them because their switching power supplies tend to be able to handle a square wave input. You know, when you're using a switching supply, it can handle all kinds of dirty power and just keep right on going. Anyway, that's that. And this is where a simple system ends, is right here. You just plug things into your inverter. But another thing you can do if you're savvy with electricity is you can come from this inverter to your house wiring if you have what is called a transfer switch. And I don't have light in that back room, but I have an automatic transfer switch. Switch is 30 amps, so it can handle most circuits. You know, you won't run your whole house on that, but it can handle most. A lot of people think these things are super expensive, but I'll tell you a little trick with that. There's two tricks actually. First trick, most low voltage wiring is going to be heavy, number 12 or larger. If you go to a Lowe's and buy 50 feet of number 12 wire, you're going to pay a very big premium for it, stranded wire. I've heard differing opinions on whether it should be stranded or solid core. I like stranded wire. It doesn't seem to get as hot as solid core wire when running DC, so that's what I use. And it doesn't seem to have as much of a voltage drop for whatever reason. But the trick, you can go down there and pay a premium for it, or you can go to Walmart, and I'll tell you about that. And you can get a number 12 extension cord, 50 feet. Make sure it's number 12, not number 14 or number 16, which is usually what the cheaper stuff is. It's still going to be a little costly, but it's going to be about a third the cost of getting that wire off of a spool. So anyway, back to what I was saying. That's a good way to get your number 12 wire cheap, is just go to Walmart and buy a number 12 extension cord in whatever length you need, because the price is going to be about a third to two-thirds cheaper than what you would pay at a big box hardware store. Believe me, I know this because I've had to buy this stuff before. I had a much larger solar setup where I was living previous to this, and wire was at a premium. And you have to have heavy wire because the voltage drops over thin wire is terrible. I was going to say something. Oh yeah, a cheap place to get a transfer switch. If you're just interested in running 30 amps or less, and you want something that's automatic, instead of paying $200 or $300 for a box that just has a little switch that with a linkage, go to your nearest RV place. They have what's called an automatic transfer generator switch. What it is, it's just a little silver box. It has your AC in, it has your generator in, and it has your AC out. And you wire it up. It's about $70 what I paid for mine. Yeah, that's how much you're all getting ripped off for. It has a heavy 30 amp relay in there. It's a little bigger because they designed some safety into it. And when you switch your inverter on, it senses the input from the inverter, it waits 30 seconds for it to stabilize, and then it flips off of AC and it goes to your solar seamlessly. You don't have all that crap to have to flip. You still have to turn your mains off, or the breaker to the circuit that you're using it on if you're just testing it, or if you don't want your inverter to get blown to kingdom come when the power comes back on. But it works, and it works seamlessly, and it's cheap. The other trick, and a lot of them don't like you doing this, but I've never had a problem with it as long as you keep it shielded from the weather. Instead of buying all those expensive fancy this and fancy that connectors, get you a box of AC receptacles and a few junction boxes with weather-tight lids. And in the bottom of your rack, instead of having to tie all this stuff together, these terminal blocks and all these fancy things, just cut the end off your extension cord that's going to the solar charge controller. Leave the plug on the other end. Put that receptacle on your solar panels. Small plug minus, big plug plus. Big slot plus. The ground irrelevant, unless you want it for some other thing, maybe data. And then take that end that you carried out to your solar panel and plug it in. That plug is rated 15 amps, and it will carry 15 amps. Even down in the 12 volt side, it'll get a little warm, but then when you're running a heater, it gets a little warm too at 120 volts. So it's carrying the current. And because if you get a good one, it's got brass connectors, and your cord's got brass connectors, it's not going to corrode. At least not as bad as it would if it were aluminum or that tin stuff they use. And that saves you quite a mint on terminal blocks and junction boxes and crap like that. Just looked at my counter. Looks like I'm about to hit the 10-minute limit, so I'm going to let y'all go, and I will see you in part 2 if you feel free to watch it or whatever. Anyway, catch you then.